Hello everyone. My name is Sathyam and I'm a third year student at Indian Institute of Information Technology, Sri City. And I welcome you all to the second session of Motion in a Straight Line, where we are discussing the previous year questions of Kinematics Part 1. So in the previous session, what we had done is that we had discussed these questions, right? I hope you all remember these questions. So we had done till question number 25 in the previous class. Yeah, so this was the last question where the solution was 7 by 5, the option number A. And now we'll begin with question number 26. So one thing I hope that you all would have revised the previous questions before what we had done. So just to quick sum up the things, I would like to tell that uh, some of the important concepts which we had discussed before was equations of motions. Okay, we had discussed equations of motions, and these equations of motions were again dealt with two ways, that was with differentiation and one in vector format, right? Then we had discussed about representation of curves, of graphs basically, not curves, graphs, where we had uh, vt curve and xt curve, right? Similarly, you can have at also, and you should even know how to do the conversion between the coordinates, right? This is one thing. And another variety of question, like maximum variety of questions were from these two, but some more variety of questions were like, how do you calculate average velocity, right? We had two, three questions from this, right? So since it is just 1D motion, you can just expect that maximum of the questions will be coming from this first part. Okay. Very rare questions usually come from this part, but again, that is expected. And this is also a very good variety of, right? So this is the sum up of the previous session. All right, let's move to the next question. Which of the following curve does not represent a motion in one dimension? Okay, so then in one dimension, right? Okay, so in one dimension motion, the body can have at a time one velocity, but not two values of velocity. So let's see where do we have two values of velocity. So just scroll this down. Yep. So this is option B. As you can see, option B. If you see the VT curve, let's discuss it one by one. Let's discuss it one by one. Let's go to option A. So if you see option A, at every instant, okay, at every time instant, there is one specific velocity, correct? So let's say that this is time t1, then we have velocity as v1, okay, and this is time t2, you have velocity v2, correct? So this is a correct option. That means that this is not the option which we are looking for, okay. As this is a single choice option, option B is the correct answer, because if you see at this particular instant, this is a circle, right? This is a circle. So if you consider, let's say, time t1 over here, and this is velocity v1, correct? Then we have velocity v2 at the same time, which is practically not possible, right? Let's say if you're traveling with a bus or a car at a specific velocity v1 at time t1, then at the same time you cannot have two velocities v1 and v2, right? You cannot travel with 40 meter per second speed and 30 meter per second speed at the same time, correct? So there's a time lag which requires to change the speed, correct? So at the same time you cannot travel with two different velocities. That is what this question is trying to this option is telling us. So this is an incorrect option. That is why this is a right option. All right. So option B is your right option. Once again, in one dimension motion, the body can have at a time one velocity, but not two velocities. Okay. At a time, it will just have one velocity, not two velocities. Correct? Fine. Okay. Sorry. Okay. Next question. A car is moving along a straight road with a uniform acceleration. Again, see, now uniform acceleration, so nothing to worry. Okay, in equation of motion, in normal straight line motion and projectile motion, you have always uniform acceleration. Fine. Variable acceleration is again a concept which you will be learning in center of mass and rotation motion. Okay, fine. So it passes through points P and Q separated by a distance. Okay, and with a velocity of 30 kilometer per hour and 40 kilometer per hour respectively. The velocity of the car midway between P and Q is. Okay, so the car is traveling between P and Q, right? Let's say that the distance between P and Q is x. Okay, initial velocity what they have given us, it's 30 kilometer per hour, right? And the final velocity v is 40 kilometer per hour. What they have said us, they have said us to find acceleration, right? So acceleration is equals to v square minus u square divided by 2 into s. You know this equation, right? V square minus u square is equals to 2as. Correct? S is given to us. Fine. So acceleration is v square. What is v square? 40 square. 40 square minus 30 square divided by 2x. This is 350 by x. Correct? So the value of acceleration is 350 divided by x meter per second square. This is okay. So we have got the acceleration. Now we need to find the velocity at midpoint. Okay. So the velocity at midpoint, Vm will be u square plus 20 into 7. Correct? Correct. That is Vm square minus 30 square is equals to 2 into 350 by x into x by 2. Why it is x by 2? Because we need to find it at a middle point, right? So first you have to find acceleration to this entire point x. Now you need to find the final velocity over here. As you have achieved acceleration, you will be finding final velocity at the midpoint. Okay. So I hope this is clear. Fine. So this gives the value of final velocity at the midpoint as 25 root 2 kilometer per hour. Okay. This question should be clear. Moving to the next question. A bus is moving with a speed of 10 meter per second on a straight road. Okay. A scooterist wishes to overtake the bus in 100 seconds. Okay. If the bus is at a distance of 1 kilometer from the scooterist, what is the speed should the scooterist chase the bus? Okay. So this question, okay, this question is of relative motion. Okay. Now let v be the relative velocity. So we basically need to calculate the relative velocity. So what will be the relative velocity of the scooter? Relative velocity of the scooter with respect to bus will be vs minus vb. Correct? Okay, this is what we study in relative motion, right? Correct? This is what we study in relative motion. So v is equals to 1000 divided by 100. This is 10 meter per second. This is v. So what is velocity of bus? It will be 10 meter per second. Correct? Now this is a scooter. This is our bus. There's a separation of 1 kilometer. The initial velocity of the bus is 10 meter per second. So since it is 10 meter per second and the relative velocity is 10, so vs is equals to 10 plus 10. You just shift, right? Shift the linear equation. So that is 20 meter per second. This is what they have given us here. So when two bodies are moving in the same direction, their relative velocity between difference of individual velocities is this one. Okay. So what this note is trying to tell over here is that, let's say this is an object A. This is an object B, right? Both are moving in the same direction. So the velocity of A with respect to B is given as velocity of A minus velocity of B. Why though? Why? Because let's say that if this is moving in this direction, okay, and this is moving in the same direction, let's say this is V1 and this is V2. So I can say that the total velocity of A1 during the thing is V1 opposite of minus V2, because if the particle B is traveling further and particle A is traveling further, then there should be some relative. Relative means there should be some difference between the velocities, right? What is the difference? You just subtract minus v2, right? So it is v a respect to b is equals to va minus vb, correct? All right. Into the next question. A train of 150-meter long is going towards north direction at a speed of 10 meter per second. A parrot flies at a speed of 5 meter per second towards south direction, parallel to the railway track. The time taken by the parrot to cross the train. So again, it's a relative motion question. Fine. So relative motion of the parrot with respect to train, what will it be? It will be 10 minus of minus 5. Why will it be minus of minus 5? Because this time the situation is that this is my train. It is moving in this direction, let's say right side, and the parrot, which is flying over here, excuse me for my drawing, it's moving towards the train, right? It's not moving away from the train. If it was moving away from the train, then we would have just you know summed it up already, right? We would have just normally subtracted VA with respect to BV is VA minus VB, correct? But in this situation, the parrot is moving towards the uh, train. That's why we are going to add it up. So the entire velocity will be basically getting added up. Okay. The best real life scenario I would tell is that, let's say you're traveling a train, all right? So the train which is approaching towards your train will be faster than the train which is going along with your train, right? So let's say if you're moving from Delhi to Mumbai, okay? Now let's say your train has departed from Delhi, okay? And another train is coming with your train on the other parallel track. Let's say the speed of this train is VA, okay? In the different situation, let's say you have moved from Delhi to Mumbai. Your train is going from Delhi to Mumbai, and in the other track, let's say your train is coming from Mumbai to Delhi. So, and this velocity is VB. So VB will be greater than. So you will feel that the train which is approaching from Mumbai, that is faster than with the train which is going with your train. Okay, that is the relative motion. All right. Okay, let's move next. A ball is thrown vertically downwards with a velocity of 20 meter per second from the top of the tower. Okay, so there's a vertical tower, right? Achha, there's just a vertically downward. Okay, with a velocity of 20 meter per second from top of tower. Yeah, it hits the ground after some time with a velocity of 80 meter per second. What is the height of the tower? See, until now, whatever the questions you had done, those were on the ground, right? So that was with respect to x-axis, correct? Now this question basically deals with everything on the y-axis, right? Everything will be same. It will be just minus and plus thing, okay? So this is the height of the tower, okay? The height of the tower, fine. So it is 20 meters. This is G, okay? So V square is equals to U square plus 2GH. Why will it be 2GH? It is because when a particular body is falling down, the acceleration due to gravity is 9.8 meter per second square. Everybody knows this thing. Approximately it's 10 meter per second square, right? Correct? So that's why acceleration over here is G. And the distance traveled is basically, in short, the distance of the tower, right? So that is H. So we need to calculate the height of the tower. So it's cross chain the equations, that is V square minus U square divided by 2G. So this comes out to be 80 square minus 20 square. What is the value of G? For now, you can take it 10. Okay. This is 6400 minus 400 divided by 20. This comes out to be 300. So the height of the tower was 300 meters. All right. Fine. I hope this question is clear. A stone falls freely under gravity. It covers a distance of h1, h2, and h3 in the first 5 seconds. Okay. in the next 5 seconds. And the okay, so basically what they are saying is that yeah, so this is a tower. So this is a tower. Okay, a ball has fallen over here. Okay, a stone. Fine, it's a stone. So they are saying that in the first 5 seconds, it's traveling h1, and t1 over here is 5. Then it is traveling h2 and h3. We don't know h3 is till the ground or in the middle. Okay, but all the time is 5 seconds itself. So h1, h is equals to half gt square. Basically, s is equals to ut plus half at square, but u value is 0 because the stone is starting from rest, right? So the initial velocity is 0. So h is equals to half gt square. So h1 will be equals to half into, I know the value of g, to 5 square, that is 125. Value of h1 plus h2 will be half g into 10 square, and h1 plus h2 plus h3 will be equal to half g into 15 square. This is equation 1, this is equation 2, and this is equation 3. I'll again draw a diagram. So what they told us is that this is the height h1. Okay, let's say h2 is this much, and let's say h3 is this much. The time taken by the stone to travel h1 was 5 seconds. The next 5 seconds, and this is the next 5 seconds. Yeah, this is better. Okay, so this is a tower. Okay, what they have told is that we have a stone, right? Let's say the stone is this color. Okay, the stone is at rest. So initially, the value of u is 0. All right, I hope this makes sense. Okay, what we have done is that stone is falling. It achieves a height of h1 in time t1 is equals to 5 seconds. Okay, it achieves a height of h2, then h3. This is h2, this is h3. t2 is equals to 5 seconds. t3 is equals to 5 seconds. All right, fine. Now what they have told is, okay, so what the question is demanding? The question is saying that the relation between h1, h2, and h3. All right. So yeah, yes. So we have h is equals to half gt square, right? Because h is equals to, the normal h is equals to ut minus ut plus half gt square. As u is 0, so this entire quantity becomes 0, and that's why we are going to get half gt square. So we'll be basically applying this formula. H is equals to ut plus half gt square basically. Okay. So now let's say for h1, okay, for h1 it will be half g. What is the time taken to travel h1? It is 5 square. Okay. Now for h1 plus h2, okay, this total height h1 plus h2 plus h2, the time is half g into, what was the time initially? 5 seconds. Then the next h2 5. So 5 plus 5, that is 10. That is why I had written here 10. Okay. Now h1 plus h2 plus h3. We are talking about this height. Okay. This is half g into 15 square. Okay. Let's solve it a bit. Solve it a bit. 5, 10, 15. All right. So h1 is equals to half to g into 5 square. h2 is equals to half h1 plus h2. half g into 10 square, h1 plus h2 plus h3 is equals to half g into 15 square. So what's the value of g? 10. Half into 10 into 5 into 5. Okay. This is half into 10 into 10 into 10, right? This is half into 10 into 10 into, oh, this is 15. I'm sorry, into 50. So this is 2 ones are 2 fives are. What is 5 cube? It's 125. Okay. This is 2 ones are 2 fives are 10 tens are 100, right? 10 tens are 100, 100 fives are 5. Okay. 2 ones are 2 fives are, right? 15 fives are 45. Okay. So let me just put a calculator. So we have 10 into 15 into 15, all right? And we have to divide it by half, that is 2. So that is 1125. Okay, that is 1125. So this is the value which you are getting. Let's verify it once. Yeah, so this is 1125, right? 1125, 500, and 125. So using this, what we can say is that H3 is 625. H3 is 625. Okay, and H2 is CH1, and H3 is 5H1. This totally sums up that H1 is equals to H2 by 3 and H1 is equals to H3 by 5. So this says that the distance basically covered in time t, 2t, and 3t. The ratio of H1 is to H2 is to H3 will be 1 is to 3 is to 5. And this was just a simple question which you done, which is a concept which is taught in a class. That let's say that if there is a particular, yeah, so this is a simple question which says that let's say this is particular, not even a tower, I should say, you know, yeah, not even a tower. Let's say that if a specific object is falling vertically downwards, okay, and the time intervals, okay, t1, okay, t is equals to t2, t is equals to t3. If the ratio of the time is something like this into 4t, yeah, then the height traveled by the specific object will be h1 is to 3h1 is to 5h3 is to 7. 1 is to 3 is to 5 is to 7 is to 9. If the time is in the ratio 1 is to 2 is to 3 is to 4 and so on, then the height will be 1 is to 3 is to 5 is to 7. You can remember this. It can be applied in any of the questions. So I hope this is clear. Yeah, this is what I have concluded, and this is one important concept which you have to memorize it. Okay, and it can be used in your, it have come in JEE Mains already. Okay, fine. Let's move back. We invested a lot of time in this question, but no worries. A boy standing at the top of a tower of 20 meters height drops a stone, assuming g is equals to 10 meter per second, the velocity with which it hits the ground. Final velocity, basically, right? So v square is equal to u square plus 2gh. See, if, now here's the catch. If, like when to decide the value of g, basically when it's positive or when it's negative. If, let's say this is a tower or anything, let's say it's a ball. If this particular ball is thrown upward, then this is going against the gravity. That means over here acceleration will be minus g in this case. The second case which I want to tell is that if this ball is coming down, then over here the acceleration will be plus g. Why? Because this is going with the gravity, right? It's going with the gravity, it's going downward. But in this situation, this is going against the gravity, it's going upward. So here the acceleration will be minus g, and in this situation, the acceleration will be plus g. Okay, so over here, it will be plus g. Why will it be plus g? Because it is coming down. So initially the velocity was u. So they are asking final velocity, u square is equals to u, v square is equals to u square plus 2gh. So v is equals to under root of 2gh. 2 into g is plus 10 and into 20. That's the height. So that is 20 meter per second. This is under root of 400. What is the root of 400? 20. So 20 meter per second. Okay, fine. Now, a ball is dropped from a high rise platform at t is equals to 0, starting from rest. Okay, good. After 6 seconds, another ball is thrown upwards. Two balls meet at, okay. So basically they're saying that at t is equals to 0, I threw a ball upwards. Okay. Then after 6 seconds, I threw another ball downwards from the same speed v. Both the balls are basically meeting at 18 seconds. What is the value of v? Okay. So clearly, distance moved by the first ball in 18 seconds will be equal to the distance of the second ball in 12 seconds. Correct? So using this, what they have done is that, so 18 seconds, right? So half gt square, that is 1620 meters, and first 12 is half gt square, that is 12v plus 720. So basically 1620 is equals to 12v plus 5 into 144. V is equals to 135 minus 60, which is 75 meter per second. Yeah, it was pretty easy question, right? Yep. Okay. So yeah, I hope it's clear. A car moves from X to Y with a uniform speed of this, the average speed. Okay. Round trip. So average speed is total distance divided by total time taken. What was the total distance? S plus S. Okay. Round trip. So let's say that this is a distance. It's going from A to B. Let's say it is S. So round trip means it is going and it is coming back. Okay. So this basically tells that what is average speed? Average speed, it is total distance divided by total time taken. Correct? Total distance is first S, then S. It's a round trip, so it's 2S. And the time taken is T1 and T2. We don't know how much it is, right? So 2S divided by S upon VU plus S upon VD. Okay. So 2VU into VD divided by VD plus VU. That is the average speed. All right. This is the average speed. Now, two bodies A and B of mass 1 and 3 kgs are dropped from height this. Okay, the mass ratio basically. If a body is dropped from some height, the motion is independent of the mass. Simple. The time taken to reach the ground is under root of this thing. Okay. And the final velocity is this. Okay. Basically, it's saying that the first equation was v is equals to u plus at. Right. S is equals to ut plus half at square. Okay. V square is equals to u square plus 2as. Okay. Sn is equals to n by 2 plus a by 2 into 2n minus 1. Right. In these four equations of motion, there's nowhere a concern of mass. So whatever my body is, it is independent of. This is as simple as that. All right. It's as simple as that. Let's move further. If a ball is thrown upwards with a speed u, the distance covered by the distance covered during the last t seconds of ascent, time of its ascent. Okay. Okay. Time of ascent is basically t is equals to u by g. Correct. So velocity attained by the body in t minus t seconds. What will it be? It will be u minus g into t minus t. This is the time of ascent. So b is equals to u minus g capital T plus g small t, which equals to u minus g into u by g plus gt, which says that v is equals to gt. Correct? So distance travel in the last t seconds will be S is equals to Vt plus half Gt square. It says Gt. What is the value of V? Gt into T minus half Gt square equals to half Gt square. So S is equals to half Gt square. It was a direct formula also, which everybody knows, the time of ascent and time of descent. Then you have your height h basically, right? Height h. It's half Gt square. I just did a normal calculation, but this was a direct option to just show you. So it's half Gt square. 2003 question. It's just like seeing and directly taking up the option correctly, right? Okay. Moving to the next question. A man throws ball with the same speed vertically upwards, one after other, in an interval of 2 seconds. What should be the speed of the throw so that more than two balls are in the sky at the same time? So let the speed be u. Okay. So what will be the maximum height? T is equals to u by g. Everybody knows that this is the maximum height. Correct? Correct. See, what is the total time to come up and down? That is 2u by g, right? Why it is 2u by g? Because first it will go up, then it will come down. So 2 times of u by g, right? So to attain the maximum height, it will be u by g, correct? So if two balls remain in the air same time, this means that u by g should be greater than 2, correct? For two balls. This says that u is greater than 2 into g. Let's say that g is around 9.8, which says that u should be greater than 19.6 meter per second, which is also approximately greater than approximately 20 meter per second. Okay. So in the previous one, it should be more than 19.6 meter per second. Okay. If a ball is thrown upwards vertically with a velocity, okay, after 2 seconds, very simple question. This is this. So u is equals to 40 meter per second. Okay. Acceleration is equals to minus g because it is going up. Correct. That means it is minus 10 meter per second square. Time is equals to 2 seconds. So v is equals to u plus 80. U is 40. What is a minus 10? T is 2. This is 20. Answer is 20 meter per second. Very simple question. Okay. So answer is 20 meter per second, 1996. One fun fact about JEE was that before they weren't giving you these options. Okay. Even if they were giving you these options, what they used to do is that they used to expect a subjective approach, like just like board exam, right? So you just make a margin like this. You write first question, then your answer properly, and they used to give marks for this subjective approach. Let's say that if there were 6 questions asked, subjective questions, if you would just complete 3 questions with full correct answer, with full subjective answer, you are into IIT. That used to be the thing. So if you're feeling that this is easy questions, it was easy questions, but again, every question was converted into a concept, right? So this is a concept right now, but that time it was a very big question. Okay, because you needed to write it in a subjective format also. There used to be some subjective format of writing the answers before. Okay. A body is thrown vertically upwards from ground. It reaches the maximum height of 20 meters in 5 seconds. After what time will it reach the ground from its maximum position height? Okay, so this is h max is 20, right? The time to come down also will be 5 seconds. Why will it be 5 seconds? If it's going up in 5 seconds, it should come down in 5 seconds, right? It's a simple thing because the time taken by a specific particle to go up and down is 2u by g, right? Correct. This is, and for maximum height, it is u by g. This is for maximum height. And this is for a total round trip from the maximum height. So the amount of time which is going up, the same time it will take to come down also. why it's option B, which is 5 seconds. Okay. All right. So let's move to the next question. A stone released with velocity, okay, zero velocity from the top of a tower reaches the ground in 4 seconds. The height of the tower is h is equals to ut plus half gt square. All right. So initially the velocity was 0. Okay. The time is 4 seconds. Right. So initial velocity u is equals to 0. The time is, let's keep it in this. Time is 4 seconds. Okay. And gravitational constant g will be 10 meter per second itself, which is plus g. Why will it be plus g? Because it is coming down. As it is coming down, I will have plus g. Okay, plus g meter per second. Fine. So h is equals to ut plus half gt square. So what is the value of u? U is 0, time is 4, plus half, g is 10 into t square. What is t square? 4. So 2 ones are 2, 2s are. That is half into 10 into 4 square. This is 80. 80 meters, right? 80 meters. Okay. Oh, this is 4 square, right? So it is 4 over here. So that's why I got confused by the answer. Okay. I hope this is clear. Three different objects are allowed to fall from rest from same point O along three different frictionless paths. The speeds of three objects on reaching the ground will be the ratio of. So the speed of an object falling freely due to gravity depends on the height and not the mass. Okay. Again, we have four equation of motion, right? Correct. First one is this. Yeah. So the first one is V is equals to U plus AT. Okay. Second one is S is equals to UT plus half AT square. Okay. Third one is V square is equals to U square plus 2AS. Fourth one is Sn is equals to A by 2 plus 2n minus 1. Okay. These are the four equations. Over here, V is my final velocity. U is my initial velocity. Right. A is my acceleration. Now this acceleration is constant. Okay. It's constant. But in real life scenario, acceleration is never constant. Okay. You never drive a car continuously for 40 meters per second, right? The next is S, that is displacement. Okay. And over here is N, it describes nth second. Okay. In these four equations, we never deal with mass. Correct. If we would have dealt with mass, then M should have come in any of the equations, right? So equations of motion are independent of mass, right? That is what they have given to us over here. The speed of an object falling freely due to gravity depends only on its height and not mass. Okay. Since the paths are frictionless, all of the objects falling through the same height, therefore their speeds are reaching the ground will be 1:1:1. As it is frictionless and it is not dependent on mass. Okay. So the ratio of speeds when they reach to the ground will be the same. That is 1:1:1. Okay. Water drop fall at regular intervals from a tap. Okay. So water drop is falling at regular intervals from a tap 5 meter above the ground. The third drop is leaving the tap at an instant when the first drop touches the ground. Okay. How far above the ground is the second drop? So, see, the tap is 5 meter, right? So, height of the tap, I can assume that the height of the tap is 5 meters. Because if a tap is falling from here and the ground is over here, so I can consider this height as 5 meters. Let's say that this is the tap. Okay. Value of G will be 10 meter per second square. Correct? Have two values. So S is equals to UT plus half GT square. U is 0, this quantity is 0. Half GT square, that is 5T square. So T square is 1, which is the T time taken is 1 second, right? Correct? Now the distance covered by the second drop in 0.5 second is the same. So instead of 1 second, you just need to add T is equals to 0.5, right? Add T is equals to 0.5. And then you need to subtract both of the S, S2 minus S1 basically. Okay, fine. A body dropped from a tower. Okay, next question is a body dropped from tower of a tower fall through 40 meter. Okay, top of a tower fall during the last 2 seconds fall, then height of the tower. Okay, so what they are saying is that yes, so this is a tower. Okay, yeah, this is a tower. My bad. Okay, so this is the tower. Now they are saying that top of a tower fall through 40 meters. Okay, so last 2 seconds, in the last 2 seconds from the ground, last 2 seconds, what will be the velocity? So in this kind of questions, you basically need to apply second equation of motion, which basically says that dn is equals to u plus a by 2 into 2n minus 1. This is the fourth equation of motion, correct? So dn is nothing but dt plus dt minus 1. Okay, this says that what is dt? 0 plus g by 2 into 2n minus 1. Okay, this is dt plus this dt minus 1. This is d. All right. So 10 by 2 into 4 into n minus 1 is the option. If you manipulate this one, if you manipulate this equation over it, dn, final dn. Okay. So s is equals to again ut plus half at square. Acceleration is constant. Initial velocity is 0, so this quantity becomes 0. A t square, t square. Basically, you need to calculate the time. So time you will be getting from fourth equation, and the final displacement you will be getting from second equation. Okay. All right. I hope this was clear. What will be the ratio of the distances moved by a freely falling object? Freely falling, okay, body from rest in fourth and fifth second of the journey. So again, what will be the speed they are basically asking, right? So this comes out to be again fourth equation of motion, x of 4, okay, and x of 5, right? So equation of fourth equation of motion basically tells Sn is equals to u plus a by 2 to 2n. Okay, this equation is to be applied. So S4 divided by S5 you have to calculate. S4 divided by S5. Through this you'll get it by 7 by 9, and Hn value is g by 2 into 2n minus 1. Okay, you can go through this explanation. Fine. If a car is at rest, accelerates uniformly to a speed of 144 km per hour in 20 seconds, how much distance will it cover? So initially the velocity of the car was 0. That is 0 meter per second. Now final velocity is 144 km per hour. Time taken is 20 seconds. Correct? Now we know that V is equals to U plus 80, right? 40 is equals to U. 0 plus 80, A into 20, 20 seconds. So acceleration of this car is 2 meter per second square. We have got the acceleration. We have initial and final velocity. So V square minus U square is equals to 2AS. From this, S is equals to V square minus U square divided by 2A. This comes out to be 40 square minus 0 square divided by 2 into 2. 40 square is 1600. 1600 divided by 4. So 1600 divided by 4 is your 400. So the car has traveled 400 meters. See, I have converted this kilometer per hour into meter per second. Okay, unit should be same. So to convert kilometer per hour and meter per second, you just have to multiply 15 by 8. Okay. Yeah. Next question. A bus traveling in the first 1/3 second at a speed of 10 km per hour. The next 1/3 second is 20 km per hour, and the last 1/3 second is 60 km per hour. Then what is the average speed? That's very easy. So what you have to do is average speed is equals to total distance, which was this is total distance. This is the total time. It's 18 km per hour. Okay. In case of continuously changing, you need to apply V and is equals to integral of dt divided by integral of dt. Okay, correct. If this is continuously happening, but they are saying that this is first 1/3 distance, then the next 1/3 time, and then the last 1/3. So this is a different scenario. This is a discrete scenario. For continuous, we will just integrate the things. Okay. Now, a car moves with distance of 200 meters. It covers the first half of the distance at speed of 40 km per hour, and the second half of distance at V. The average speed is 48 km per hour. Find the value of V. So, see, they've given us the total distance 200 meters. Okay. What is the speed in the first half? 40 km per hour. Speed in the second half is V. So using total distance and the total time, what we are going to do is we are going to calculate V average. V average is given to us, right? So the V average, since the V average is given to us, there's no much of issue, right? Because V average is equal to total distance by total time taken. And the total time can be divided into two chunks over here because we have two halves, correct? And speed is equal to distance by time. Okay. Just make sure of one thing, that this is kilometer per hour, right? If it is in kilometer per hour, then make this distance into kilometers, into 10 to the power minus, right? Just do it into 10 to the power minus 3, you'll have kilometers. If maximum quantities are in kilometer per hour, and if your options are in kilometer per hour, then you have to do it. Yeah, your options are in kmph. So you have to convert this meter per hour into kilometer per hour. Okay. It's a pretty straightforward question. Total distance was 200 meters, which is 200 into 10 to the power minus 3 kilometers. Correct? Kilometer. And so, all right. Let's move to the next question. A car covers the first half of a distance between two places at 40 km per hour and the other half at 60 km per hour. Okay. The average speed of car is, what is the average speed of car? Again, simple question. S by 2 divided by 40 plus S by 2 divided by 60. So you'll get S by 48. That is the total time taken. Okay. And the total distance is already S. So if you put this in this equation, like this is equation 1, you put it in this equation, you get 48 km per hour. That's what the explanation they have given over here. Always note that V average. What is the average? The average velocity is 2v1 v2 divided by V1 plus V2. All right. You have to get up. This is an important formula. Okay. Okay. So the final question: if the velocity of particle is v is equals to at plus bt square, where a and b are constants, then the distance traveled by it between 1 second and 2 seconds. So distance traveled between 1 second and 2 seconds, right? So v is equals to at plus bt square, correct? Which means dx by dt is equals to at square. Oh, sorry, at, right? Is 80. Yeah, at plus bt square, correct? Now we have to integrate. Why we have to integrate? Because it is asking between 1 second and 2 seconds, right? So integral of 0 to x dx is equals to integral of 1 to 2 at plus bt square into dt. All right, this part is clear. Fine. Now we just have to integrate this stuff. Okay. So what is integration of dx? Integration of dx is x, which is equals to what is, so let's split this up. So this is integration of 1 to 2 at square, at dt plus, okay, let me do one thing. I'll just rub this. I'll put this up. Okay, so I hope this part is clear, right? This part. We'll just have some space for integration. Yeah. Yeah. So x is equals to integration 1 to 2 at dt, right? Plus integration of 1 to 2 bt square dt. Is this clear? Right? So this is what we have. This comes out to be x is equals to a into, since it is constant, 1 to 2 t dt plus b outside integration of 1 to 2 t square dt. Now everyone should know the formula for integration of x to the power n dx, which is x to the power n plus 1 divided by n plus 1 plus c. Okay, so this is a into, okay, t square by 2 from 1 to 2 plus b into, okay, let me just make this a bit. Okay, so this is x is equals to a into, this is t square by 2, correct, from 1 to 2, right, plus b into t cube by 3 from 1 to 2. Okay, and this is in 1. a into a into uh, 2 square, that is 4 by 2 minus 1 by 2 plus b into 2 cube is 8 by 3 minus 1 by 3. I hope everybody knows this. So a into 3 by 2 plus b into 7 by 3. So this comes out to be 3a by 2 plus 7b by 3. I hope this is the answer. 3a by 2 plus 7b by 3. Yeah, this is our final answer. Okay. So 3a by 2 and 7b by 3. Option C is a correct option. Okay. So it was nothing. You just need to integrate this. So this is dx by dt, right? Dx by dt is equals to at square plus dt. A and b. This is a and b. Okay. You just need to integrate it from, because it is traveled between these, right? So that is a continuous travel, right? It is a continuous travel from time t is equals to 1 to t is equals to 2. Correct? Okay. So this was it. Yeah. So this is the final questions which we had done. Now, a request to all of you is that just revise the concept. Okay. The first part is equation of motion. Okay. Make sure you're good with differentiation and the vector representation. Okay. Then you have relative motion questions. Okay. We had some relative motion question. Correct. Then we also had average velocity, right? But that again comes under these equations of motion only. But it's okay. And some of your graphical questions. Okay. And if you're thorough with this, then I think motion in straight line, you're through with motion of straight line. Okay. So this is it for this class. Okay. And keep practicing. We'll be meeting in the next lecture. Okay. Until then, stay safe and take care. Bye.